What is up? All right, so now we are going to talk, well, in the last video, we talked about the secure router configuration, right? And now I'm going to talk about NAT. I'm not talking about that annoying thing that's buzzing in your ear. I am talking about network address translation. We're also going to talk about DMZs, the demilitarized zone. And then, of course, tomorrow morning, we will investigate remote access and telephony. So let's talk about NAT. What is NAT? Before we get into NAT, I think it'll be helpful if I gave you a little illustration. So let's say me and you, we're good friends, right? You know, we're cool. And we decide, let's say we live on a different planet or something like that, and there's really no internet. For some reason, it's like a planet that's back in time. So there's no internet or anything like that. But we want to communicate, but we don't want to have to like get up and like, you know, walk to each other, and you know, I don't want to have to send you something in the mail. So we use computers to do it, and I give my computer the IP address 0.0.0.1. I know it's not a valid IP address, but just hang in there with me for a second. And then you give yourself the IP address 0.0.0.2, and it's really convenient. We're able to chat, we're able to send messages back and forth, even files. Everything's really quick. We live 10 miles apart, so it's good. It saves us a lot of time. Let's say, some of our neighbors, they kind of catch wind of our idea, and they're like, man, we want to get in on this project that Vonnie and this guy, his friend has. And so we give them the IP address 0.0.0.3 and 0.0.0.4. And we just keep doling out these IP addresses. Like, so everyone has an IP address, everyone can communicate, everybody is happy, all right? But time passes, and there's a neighboring town, the next town over, they get wind of our idea, and they're like, man, this is pretty awesome. What Vonnie and those people over there are doing, it's pretty cool. Let's go ahead and like do what they're doing over here. So they create the same IP addresses. They use 0.0.0.1, .2, .3, .4, .5, and everything's cool for that particular town. But then one day someone decides, hey, let's go ahead and try to like connect these two towns together, right? It would be cool if we could connect these towns, but it doesn't work because they're duplicate IP addresses, right? We both have the same addressing scheme. And so that's one of the reasons why the American Registry for Internet Numbers came into existence. ARIN is what people call it. It's basically kind of like it's what the FCC is to frequencies. It's what basically the internet is to IP addresses, ARIN. And they're responsible for doling out private IP addresses. They give, the 192.168, the 10 dot, addresses, the 172.116s. The 172.16 addresses. And they hand out these addresses, but the thing is they're private IP addresses, which means they're not routable on the internet, which is a problem, right? I mean, how are you going to get on the internet with one of these private IPs? And lots of organizations out there are using these private IPs. Most organizations have the 10 dot numbering scheme, so you might have a host in a large company that has a 10.0.0.5 IP address. And if an ISP, an internet service provider, gets a packet with a source IP in that private addressing space, it's going to drop it. Okay, it's not even going to bother trying to route it because it's not routable. Got to switch hands. Okay, so what happens? That's where NAT comes in, network address translation. So there's actually 3 kinds of NAT. You should be aware of these. And the first is what I like to call a one-to-one mapping. It's static NAT. And you have this internal IP, let's say it's 10.0.0.1, and it maps to a public IP, like 20.0.0.1. And so the router basically takes that incoming packet, swaps out the source IP, so it swaps out the private source IP for a public source IP, sends the packet on its way. When it gets to the destination then sends the packet back to the public IP, which is usually the NAT router, and then the NAT router swaps out that public IP for the internal private IP of whatever device is on your local area network. This is fine, except you need a one-to-one mapping, right? You need to have just as many internal IPs as you need public IPs, and that's always not possible because it costs money for that. And so sometimes companies will use something known as, well, there is one case where they'll do that situation, and it's when you have destination NAT. In that case, you have, let's say, a web server or an email server that has a private IP addressing scheme, like 10 dot something, but you want people to be able to access it from the internet. And so you would map the destination IP address. Let's say the destination is like 23.0.0.1. You will map that destination IP, 23.0.0.1, to 10.0.0. whatever I called that internal IP of that server is. I forgot what it was, but you get the idea, right? You're mapping the destination IP, the public destination IP, to an internal private destination IP. That's DNAT, or destination NAT. Now, PAT, if your name is Pat, then hey, what's up? No, but PAT is port address translation, and this is where you can have hundreds of thousands of computers on your internal LAN that are able to communicate with the internet through either one public IP address or a group of public IP addresses. And this is interesting because the TCP/IP standard basically says you get 65,536 possible ports, and most of those are reserved anyway, so you can't use all of them. But every time you open up an internet-aware application like Exchange or Microsoft Internet Explorer, hopefully you're not using that, but if you are, Internet Explorer, whatever you're using, you're going to get assigned a randomly generated source port. And that's just so that when your connection goes out, you have that private IP address with your source port that was randomly generated. Your router does some network address translation, and it swaps out that private IP for a public IP. It keeps that source port though. And so, for example, if the source port was 5,000, let's say that was the source port, and your private IP is 10.0.0.1 and your public is 23.0.0.1, the router would swap out that IP to 23.0.0.1 and it would keep your source IP, source port of 5,000. And that's fine, except when you get more than 65,536 connections, what happens? What if you have more? Let's say you have 100,000 hosts on your network, like your large organization. You can only map those connections up to 65,536. And that's where dynamic NAT comes into play, where you can actually have a pool of public IP addresses. And when the first public IP is exhausted, meaning you've exceeded that 65K limit, it'll just move to the next public IP in that list and continue mapping source ports that way. So that's pretty much how NAT works. I mean, that's really what it does. It's not really that complicated. Even the configuration isn't that difficult. That's all you need to know for the test. As far as the DMZ is concerned, that's kind of like a buffer between the internet and your internal network. Usually you've got the internet on the outside, then you have a firewall, then you have a DMZ, which includes like web servers, email servers, that sort of thing. Basically resources you want to be accessible from the internet. And then behind that you have another firewall, and then you have your LAN. And so the idea is that the first firewall permits access from the internet into the DMZ. So people on the internet can get to the DMZ, but it won't allow them into the LAN because the second firewall will block that. And so it's a way of sort of creating like network segmentation. You can block off certain parts of your network for different reasons and purposes. So that's all it is. That's really it. And that's really all you need to know. If it sounded confusing, go back to this video and review it. But that's pretty much all you need to know for NAT and a DMZ. Tomorrow we're talking about remote access and telephony. And go ahead and leave a comment, scroll down, thumb this video up, hit that subscribe button, baby. And I love all the subscribers. I appreciate everything that you guys are doing. Leave comments, ask questions. I'm jumping in the comments. I'm responding. I see what you guys are asking. I am not ignoring you. And I will see you tomorrow morning at 8 a.m. Eastern, 7 a.m. Central. Peace out.